All right, let's take a look at a problem. This is an exponential growth question from our quantitative reasoning math 1030 or 1035 course. So originally 200 wolves were transplanted, and after 3 years the population had grown to 747 wolves. If the population grows exponentially according to this specific formula, we answer the following questions. So P sub t would be the final value, that is 747, equals P sub 0 is the initial, 200, times 1 plus r. We don't know the growth rate, but we do know this growth happens over 3 years. So we can solve for r. We divide by the 200. We have 747 over 200. Equals 1 plus r cubed. Now, in order to solve for the r, we need to get rid of the exponent. The exponent, we can do the cube root. I'm choosing to do the 1/3 power because some people don't know where their cube root button is, but everyone has an exponent button they can find. We have 747 over 200 to the 1/3 equals. Now on the right side, the 1/3 times 3 is 1. And so we just have 1 plus r to the 1, or 1 plus r. Finally, we can solve for r by subtracting 1. We get 747 over 200 to the 1/3 power minus 1. So taking a look at the calculations, we would have parenthesis 747 divided by 200 to the parenthesis 1/3 and then minus 1. This gives us a decimal form for r. 0.552 if we round. Now, the rounding instructions say round to the nearest tenth of a percent. So we want to go to percentage and then round that to the tenth. So in percentage, this would be 55.154-ish. R is approximately 55.154. And then we want to round to the nearest tenth of a percent. So that would be 55.2. Now the purpose of rounding is because they asked a specific rounding question. Here we see the 55.2 is the correct answer. However, it's not the answer I want to use for the rest of the problem. Next up, part B. So that's A. Part B, if this trend continues, same model, same growth rate, what will the wolf population be in 10 years? So this would be P sub 10, sub t, that's what year you're looking at, equals the initial, which is still 200, 1 plus, I'm going to write a r even though we have the value for r, to the 10th power. Here's where we find the power of rounding. So I have this value. This is the actual value for r, not the rounded value. I'm going to store this in my variable x on the calculator. And I want to demonstrate if we do 200 times 1 plus, if I do the 0.552, which is the rounded answer they asked for in part A in decimal form, I get the answer that the student went for, and it was marked, it should be, I don't know why they rounded up, rounded the nearest wolf. This should have been rounded down to 16,216. The rounding up, that's a mistake in rounding, but it's all a mistake compared to how many wolves there should actually be based on this model. So what we're seeing is that if we use a rounded answer to find another answer, the error in that rounded answer gets worse. The more times you use a rounded answer to compute something, the more that rounding will get worse. We don't want that. So even though they ask for a rounded answer, that doesn't mean we have to use that rounded answer. So instead, I'm going to use 1 plus the r that I stored in x, this whole value, to the 10th. And now we will get the correct answer. Rounded to the nearest wolf, that would round down 16,168 wolves. It is so important for you not to use a rounded answer to compute another answer. Don't make a mistake and then compound it in finding something else, because your mistake gets worse. So, get the exact answer. I have it on the top of the calculator. Round it so you can enter it into the homework and get full credit there. And for part B, go back to the exact answer to compute the second one, and then round that to put into the computer for the answers. And then go back to, you always want to go back to the original information, not using a rounded answer. All right, last question. If this trend continues, how long will it take for the population to grow to 1,000 wolves? Round to the nearest 10th of a year. All right, so for part C, let's see, for part B, this was 16,168 wolves. Part C, when will it be 1,000 wolves? And what we have is the real value for r, but I'm still going to write it r, to the t. Okay, divide by 200. We now want to solve for t. Let me highlight it. We're trying to solve for t, not r. We know what r is. I just didn't want to write down that big long decimal when writing it as r is such a nice way to write it. So we divide by 200. That gives us 5 equals 1 plus r to the t. Now the step to get rid of the, or solve for t, is the natural log step. That allows us to bring this t out in front. Okay, so that is now natural log of 5 equals t times natural log of 1 plus r. And keep in mind we know what r is. Then dividing by that natural log of 1 plus r, leads us to what t equals. T equals natural log of 5 divided by natural log of 1 plus r, which is approximately, we go back to our calculator now, and I still have stored that r in the variable x to use for later. So we have natural log of 5 divided by natural log of 1 plus x. No rounding involved in this calculation, so I'm not making a worse error out of an error. 3.66 rounded to the nearest 10th of a year, how we get the answer 3.7. All right, I hope this helps.